this video, we're going to find the domain and range of each function graphically. And we're going to state the domain and range of the following functions in both set builder and interval notation. Okay, so these are a couple of examples of what rational functions look like, or what many of them tend to look like. They have what are called asymptotes. So any of those values, if you have a formula for the graph and you set the denominator equal to 0 and you solve that and you get that x can't be some value, typically on the graph that's going to be what we call a vertical asymptote, right, at that value of x. So it's an asymptote is a line, vertical or horizontal, that a function is trying to tend toward, but it's never going to reach it or cross it. So the vertical and horizontal asymptotes of a rational function tell us a whole lot about the domain and range of it, okay? So in this first example, we're going to look at this graph of h of x. We see that it has a vertical asymptote at x equal 4. You see that red dashed line there? That is basically saying, okay, the graph is not, it's tending toward that vertical line, but it's not actually going to touch that. There's not actually going to be a y value associated with that value of x. So we have to exclude it from the domain. So for this graph, I would say the domain is the set of all x such that x cannot be 4, right? Because that's where our vertical asymptote is. And in interval notation, I would say negative infinity up to 4 in union with 4 to positive infinity, okay? And for the range, remember the range is the set of all possible y values. And I see that we also have a horizontal asymptote, it's dashed in blue there, at y equal to negative 3, okay? So remember that the equation of a vertical line is x equals some value. The equation of a horizontal line is y equals some value. So the range, I would say, well, we have the set of all y such that y can't be negative 3, right? And it appears, you know, looking at where the arrows are headed up towards positive infinity and down towards negative infinity on either side of the vertical asymptote, that all of the other y values of the function would be included except for that horizontal asymptote at y equal negative 3. So in interval notation, we'd have negative infinity up to negative 3 in union with negative 3 to positive infinity. So now let's look at this graph of f of x, this other graph, and we notice the graph of f has two vertical asymptotes. That can happen. You can have multiple vertical asymptotes. That can happen. You can have multiple vertical asymptotes. In this case, we have one of them is in this case, one of them is at x equal negative 1, and one of them is at x equal 1. So I would say that the domain is the set of all x such that x cannot be positive or negative 1. You can do that when you have a positive or negative value. Just say plus or minus whatever that is. In this case, we have plus or minus 1. Okay, so in interval notation, negative infinity up to negative 1, right? And then we do have values between negative 1 and 1, right? And then we have to exclude 1, and then we have a third interval from 1 to infinity. Okay. Now the range, I want to look at the range. It looks like we have a horizontal asymptote at y equal 4. Okay, but be careful here because the range is the set of all possible y values. So I have a question. Is there any y value function on the function happening here, like between 0 and 4? There's nothing there, right? Like the graph is settling down onto that horizontal asymptote at y equal 4, but only on the top of it, right? There's nothing happening underneath. So the range, I think it might be easier to list that in interval notation first. So I'm going to have negative infinity up to 0, right? And I want to include 0. It looks like it touches the origin there. In union with open bracket at 4, we can't include the horizontal asymptote, up to positive infinity, right? So I'm essentially excluding an entire interval from 0 up to 4 there, right? Okay, so in set builder notation, this would look like the set of all x such that x is less than or equal to 0, or x is strictly greater than 4, is how I would say that, okay? Also, one other thing, typically, again, when you're asked about domain and range, you'll likely be asked to put it in set builder notation or interval notation. I did both here because I want you to be comfortable with both of those notations.